Hello everyone, my name is Cherie Ledoux and I'd like to welcome you to today's webinar, Incident Management with BlastLogic. Today you're going to learn about Maptek's blast management solution. Your host is Steve Putt.
Thank you everyone for joining. I know this can be somewhat of a stressful topic for some of you, so hopefully you can learn a few things about how to reduce that stress with BlastLogic. Before I get started, just a little bit of background. I'm a mining engineer. I've had about 8 years of drill and blast experience. That was starting with BHP down in New Mexico, and then moving with Orica over to Australia, and then to a small consulting firm where I dealt with mainly blasting projects, electronic timing and vibration. And with that, I've probably visited or done significant work at about 20 mine sites, and all of them seem to have a similar problem when it comes to data management. And this problem was typically really vibrant when an incident occurred. So watching people shuffle around through paperwork and really try to figure out exactly what happened in the pit and what caused the problem. And when I mention incident, or I guess first I'll start with the agenda today. So most of the conversation is going to be around just identifying and troubleshooting some of the issues that we can come across when there is an incident. And with that, we'll end up reviewing some post-blast reporting, some related documents to our blasts, explosives loading versus design, drilling history, also design versus actual, and then some audit trails with that. And then we'll kind of wrap up by just showing that this information is not only good for finding the causes of incidents, but also to help prevent them, and hopefully to help quickly improve your operation and kind of track your progress. Now, when I talk about blasting incidents, the main factors we usually come across are if you had some sort of oversize where you had to do secondary blasting, and that's usually just a budget time crunch, so you're falling behind on production. There's also, of course, personal injuries, which always we want to avoid. If they do occur, there's pretty much a guarantee that there's going to have to be some sort of report or investigation. And the same with typical equipment damage. And then the unmentionable is, of course, a misfire. Misfires usually always require an investigation. So when you have any of these problems, typically you've got to get some data together. That typically starts with just getting the location in the field of where the problem occurred. So that's usually a surveyor just kind of telling you where the area is. From there, once we know the location, we can bring that into our design packages and kind of see what the design was in that area and how it may have caused some of the problem. And that could be your drill design, your tie-up design, your loading, and even maybe some kind of third-party applications where you're doing vibration control and things of that nature. Then we want to move and find some of the actuals, and typically actual data is either logged on paper, somewhere in Excel maybe, and these examples would be, let's say, a blast report, your explosives loading, or your measurements down the hole. And then, of course, pictures and videos can be very helpful in seeing what the problem was. Typically, that's where a lot of places might start, is just by watching the video. Sometimes the problem with videos is that you can't find them, or they're maybe named a little bit weird and they're hard to track down. And then, of course, all of this hopefully is stored in some sort of database, so you'll have some summary information that you can kind of look up. And then the minimum, this is usually stored in Excel. And what I'm going to show today, I guess, is that going through this process can be quite manual and can take quite a bit of time, sometimes up to a week, or even can linger on for several weeks when you're done with the meetings and the full investigations. So today I'll try to show that with BlastLogic, you can have a pretty good picture and you can have all the information in about 20 minutes. So with that, I'll jump into the software. And we'll start the story. Let's just say that we've got some complaints about hard digging in the pit, some significant maybe equipment damage, and the process is started by the surveyor going out, getting some field data, and showing us exactly where the problem is. So this polygon in the pit here is kind of what we've received from information from the surveyor. So we'll go ahead and just have a look in the pit where this lives. You can see it's probably towards the toe of a certain shot. We're not really sure. All we have is this polygon. So what I'll first do is get rid of our topography. And what I'm going to do, at least to start out here, is use our workflow manager. So just over here on the right, this little panel is just kind of a little automated workflow that you can create for really any job. I've just done it here to kind of show off and also help myself go through this webinar. So I'll just start with the first step. And the first step here is to load holes. We've got this boundary here that we want to see what was going on with. So what we can quickly do is just load holes spatially by this polygon. So what that's going to do is just assume that up and down as far as we want, we're going to get some information for blast holes, but you can also dial down that Z range and maybe just pick within the RL that you're working with. So we'll go ahead and load these holes. And what that does is give us a search result down here that we can drag in. And now we've got all the holes loaded into the system that are in this area. And I'll just move these a little bit into the view so we can have a better look. So right now what we're looking at is the holes as they were drilled. So you can see that they're not exactly perfect. No drilling pattern ever really ends up being perfect. So you can see some of the variation already. The design was likely below this surveyed location where the hard digging is. So that's just some quick visual information. And we can also see that there's a bit of an oddity over here. This E11 hole is gray, and it's quite a bit shorter than the rest of the holes. So I'll just zoom in a little bit over here, and let's find out what's going on with this hole. So we just go into our properties of the hole, and you kind of get a full history of what's happened, kind of a full story of that hole. We can see just quickly it was abandoned on this date, and it's because it was collapsed according to the crews that went out on that day. But if we come into our history, we can see the design hole was at 51.4 feet, and then when it got drilled, it actually ended up being 16.4 feet. So a bit of confusion maybe on whether this was actually just not drilled deep enough or if it actually was collapsed. But from the drilling information, we can see that it just in fact wasn't drilled deep enough. Then we can see the date that it was abandoned. We can also see when that shot was fired, who the shot firer was, and maybe we can talk to him a little bit more about this particular hole or the driller. So that's just some quick information about one hole. So let's just have a couple of looks at some different ways to view our holes. I said that this is as drilled. We can also look at features like the water that was down the hole. So this is data that would have been collected by our tablet. You can see a darker blue and a lighter blue. That's just showing you water and wet sides down the hole. We can also continue to as drilled. So here's your perfectly inline holes. And we can see that this E11 was in fact supposed to be drilled at full depth. We can continue on to drill depth variation. So this is a really good view of just how the holes were drilled as far as depth goes. Now we can see automatically that hole we talked about earlier was in fact just not drilled all the way, and there's even a hole next to it that had a bit of a problem as well. So we're already a few feet short on this hole. But that's just kind of explaining this area over to the right. So I'm wondering why this polygon is so large. So we'll just keep looking through our view types. And right now we're looking at actual charge depth variation. So this could be that you wanted to drill a bit deeper than your charge level. And maybe the holes have either backfilled or some fallback from the cuttings. Maybe the crews have just gone out and added too much gravel to backfill the holes. So this kind of shows us that these two problem holes we had originally are also still an issue, because obviously we can't load further than we've drilled. But there's also quite a few holes in the middle here that have been either backfilled too far or some other issue has caused them to be not loaded with explosives all the way. So we'll just continue through our view types. We can now see our actual explosives loading. Just by nature of how I've set up the software, I know that orange is ANFO, and these purple colors are different types of emulsions. So now kind of curious why the holes have been loaded kind of half with one product and half with another. So to dig deeper into that, we'll look at our design. So here we're looking at just our explosives design. And quickly a question should come up of, I mentioned that the orange is actually ANFO. So why have we loaded ANFO into holes that we know had water in them? So that'd be a question for the engineer, and maybe there was some sort of time crunch where the design actually didn't go out properly. So those are just kind of the views that we can look at quickly. So we can already tell, without doing much work, that this whole region on the right here definitely had some issues. So So what we'll do is just select all of our holes, and now we'll have a look over here on the left, just what blast that these holes belong to. And we can see that they're actually split between two blasts. So this B5 and B2 blast both have some holes in here. And what we'll do now, I'll just continue with my workflow. Go through my pause, and we'll have a look at the blast summary reports. Now these are what we call live menus, so I'll have to select our B5 pattern first, and we'll just have a look which holes are in B5. So these holes over to the left are the B5 pattern. You can see the drill holes as drilled, and we've got a few options here. We can look at the dates, the shot fire, the powder factor, explosives loading, but also come in to see if there were any misfires, and it looks like there were 3. So that's going to be a pretty big problem in this shot as well if we've got a couple of misfires. And we'll come back and review these later, but this is just a good idea of what we should check later. So continuing on, we can also look at the charge summary, so exactly what products were used. We've got our explosives, we've got our downhole, and then our boosters as well. And then, of course, stemming. Performance indicators, so these are all kind of custom features. We've got fume level 2, we've got heave with 16 feet, vibration, overpressure, whether there was property damage, and even if you wanted, you could have a crusher power consumption if you were recording that accurately. And we also have inventory usage, so this is also going to add your surface connectors as they were reconciled based on your delivery dockets or your delivery paperwork. And we can also then, we'll just have a look at B2 and see what the story with B2 was. Again, the layout, we've got our abandoned hole that we looked at earlier in the middle, and we've also got a misfire in this. So we've already got 4 misfired holes in this area, which indeed helps explain the fact that there would be hard digging. And again, charge summary, we can look at the performance and then the inventory. And I'll continue through the workflow. So we know that this is 2 different blasts, but let's just quickly have a look beyond the blast summaries. Let's look at every individual hole and all the information associated. So I've just got a custom filter here that we'll have a look at. As you can see, I'm only selecting a very small amount of information that's possible. Like I said, essentially this is every little bit of information that belongs to every hole. So we'll have a look just what this gives us. We can see on the left the blast, so we've got B5 and B2. Again, we can see that this was multiple blasts. We've got our abandoned hole down here at the bottom. We can see the comment associated with that abandoned hole that it was called collapsed. We can see all the blast properties that I showed earlier, the fume, the heave, vibration, all associated with those holes. The dates they were drilled, the operator, the drill, the depth error, if we want to filter by that, we can have a look at the problem holes, water lengths, firing data, and etc. And like I said, there's a lot of information in here. So what I'll quickly do is just have a look at these misfires. So here we've got 4 misfired holes within this group of holes. And you can kind of select each one and it'll show you where it lives. But we can also just select all of them. And we'll refine our selection, and that'll just give us these misfires in the table and on the screen. So now this really does explain the whole story. We had some drilling problems over on the right, a misfire, we had some loading issues in the middle, we've got products that maybe weren't the best for the conditions, and in addition on the left side we've got misfires in a row of 3. So that's certainly not going to be helping the guys out there digging. So I'll just close out of this and we'll continue. So what I'll do now is just load. We know that there's these total blasts involved. Let's just see all the holes in these blasts. So we'll load these up, and this will hopefully give you a bit of a better picture of exactly what's going on here. So here we've got our 2 blasts and then our problem area, and we can again sort through our, let's look at our charge depth variation to maybe see if there were some other issues. Yeah, we've got a row of holes here that was probably not ideal for charging. And then you can see that, for a hole, the rest of it's not too bad. So something else that we can do that's pretty helpful is look at kind of embedded data into these shots, and these are called attachments. So we'll just look at B5 by selecting B5, and we'll go to our attachments. Now, attachments can be any type of file that can be stored in your computer. It doesn't have to be viewable by BlastLogic. For example, we've got a video in here, and I won't show just because they don't appear on webinars very well. But I can look at this picture. So this is just a JPEG that was attached to the blast. That'll load up, and we can quickly see a picture of the shot going off. So we can also look at other things, for example, maybe some information that was loaded in the software, such as the volume. We can just have a look at the total volume that we had there. And let's see some other information we've got. General surfaces, we've got some other pictures, a PDF report, and even external file links. So let's say that we just had some data that we knew was stored somewhere else on our network. We can have a look at that, get our picture, and then you can also just go and open that file location to see some more information. You can see someone's already started a hard dig report, so they're trying to gather information on what's happened. And let's just look at our, for example, our vibration trace. This could be pretty helpful. So this could have come from any report you had or some sort of web base where you had all your vibration information. So again, just kind of gives you an idea that we can really store whatever you want. Some people have asked about bore track information. We can certainly have that in there as well. And let's just say that this vibration trace has kind of wanted you, or it triggered you to maybe look at the timing. Let's say there was an issue in here where you went, oh, well, I want to see what happened at that time. What we'll do then is just open up our second view, which has our timing information for these shots. So again, you've got multiple blasts here, and you've got multiple tie-ups on the screen, and these are the actual final tie-ups, and you can tell just by seeing that they're called actual. So these are the final published designs. And what we can do with those is just generically see within our influence, probably the most significant factor is this box cut happening right here, so maybe that was a contributing factor. Again, we have an overview of our explosives loaded. You can see the orange and the purples and where they live in the tie-up. And we can also come in and look at some of our modeling features. I'll just pull up our contouring of these shots. There we go. So you can see each blast, kind of what they had in common, how they were timed, and you can, of course, bring these in, rotate as you need, and maybe adjust your contours. On top of that, we can also look at our actual inventory that was used, so the surface lines or down lines that were used in these shots, simply by coming up to our information and filtering out any of our stock takes or received or dispatched. We just want to see consumed, as in these were used in a shot. And we can find, here's B5, we can look at the reconciliation, what products were used. Maybe, for example, your down lines were not exactly what you wanted to use. These are both kind of at equal depth. I'd say maybe you wanted a longer downline and then a shorter downline for the top. And they've also used the same downhole delay, which, depending on your application, this is typically not done. So again, just some more information. And this was in the shot summaries that we looked at earlier. We don't want to pass through, we want to cancel. And then, like I said, other features like stock takes you can have a look at. We'll just go receipts. Here's a stock take we can have a look at as well. All we got that day was gravel, but you can see all the information's in one system. So that's kind of an overview of how fast we can gather information. So what I'll touch on now is exactly, it's great that we had an incident and that we could find all this information, but I guess ideally you don't want to have the incident in the first place. Or if you do know of a problem area, you want to be able to tell your production crews ahead of time before they get to that hard dig or misfired area. So I'll just show now some quick tools that help us do that quickly. My favorite feature is the blast tabular view. So we looked at whole tabular view earlier, but now let's look at our blast tabular view. So we'll select all of our blasts, and let's look at everything. So this is basically summarized information for every blast as you've put in. So we've got some custom properties here, and as I go to the right, we'll have some just normal properties of the software. So you can quickly diagnose problems. Let's say you wanted to look at the best to worst fume or the best to worst vibration, and let's say we just want vibration over 10 inches per second. We can just highlight these and look at what they have in common. So things like who fired the shot, when it was shot, the volume, the hole count. We've got misfires in these holes and these blasts as well. Everything down to the drilling information, the summaries of powder factor, and then even further to your, like I said, your accessories used, so your downlines and surface connectors, and all the way to your actual explosives products that you used. So as you build a bit of history, this can be a really handy tool of before you even design a shot, you can kind of look at similar shots in the area and figure out what went well and maybe what went not so well. If you're a more visual type, you can also look at this information by using our surfaces. So for example, if you wanted to model water in the pit over a couple of different blasts, you could have a look. So this is across 4 or 5 blasts in the pit. You can see that there's a lot of water in these areas, so maybe you want to just check the high wall and see, maybe there's a crack or some sort of inflow of water in these 2 areas based on your surfaces. We can also look at things like your depth error. So as the drill has finished, we can kind of dump a surface that shows the warm information. The warm, the reds and the oranges is going to be under-drilled, and the blue is going to be over-drilled. So this could be helpful to compare to maybe a final dig surface, or to just give to your operators before they start digging and saying, look, these red areas are going to be a little bit tough, so don't go overkill and think that you're going to hit target, because you might not. So we also talked about misfires. Ideally, as we said, if there's a misfire in the pit, everybody should know about it beforehand. So one quick way to do that with BlastLogic is just doing a search for any hole that's been misfired, and they'll show up on the screen. And of course, you can see exactly where they live. There's a few here in the pit. And this is something that you can always be updating and showing, just your active misfire map in the field. And hopefully that prevents a lot of incidents before they occur, even if it's, having the misfire is one thing, but having a truck or digger run into that is a whole other problem. So that's kind of where I leave the software. I hope that you guys have seen that what can be a very stressful and long process is quite manageable in BlastLogic when you have all the data and you've been building the information as you go. And this information, of course, for us is usually how it works is we tap into the drill navigation systems, and we also have the BlastLogic field tablet that helps you capture your hole measurements, your explosives loading, your backfilling, and even your post-blast reporting. So with that, I'll go ahead and wrap up and turn it over to questions. I hope you guys enjoyed.
Great, thanks, Steve. So it looks like we do have a couple already, Steve. The first one here is, you showed explosives data in the system. How does that get entered?
Yeah, as I mentioned, there's a field tablet that I think if you look around on the website, it shows you kind of the views of the tablet. But essentially, you get your design information and your actual, so the crews will see a designed loading based on conditions. So let's say there was, I don't know, water in the hole, it'll actually show from a dry product to a wet product if you did find water. And then that gets stored as you actually load the hole based on just a few quick button presses. You can have your holes actually loaded, and that information comes back into the system. It's just kind of like a wireless link that automatically comes in. If you want a view of the tablet, I'm certainly happy to do a demo of just the tablet. I hope that answers that.
Okay. You showed downhole leads and surface connectors stored in the system. How does that work?
So our inventory management basically works by using the field tablet to get your explosives information, but then on top of that, the tie-up designs will assume that you're going to use exactly what went to the design. So you then reconcile a blast, and it's going to say, all right, did you use all this design information? You can say yes, or you can actually use the dockets that the crews bring back to you. For example, maybe they dropped an extra booster down the hole. You would just log that when you do your reconciliation. And that also shows up in the stock takes and things of that nature, and just gives you a full history of kind of how that information was built. So it kind of starts by assuming design, and then if you want to make changes, you just do that as you do the reconciliation, and it's all stored.
How are misfires handled when they're dug out? Are they still tagged as misfires, or does the information get lost when they're cleared?
That's a good question. The system currently only handles active misfires as you've checked off active misfire. So they would actually disappear, but there's a few ways to handle this. One would be you can search for misfires, let's say, just in November, and that search will contain all that information unless you actively refresh it. So you could maybe list month by month what misfires you had in that month, or you could just create a second custom field that was previous Misfire. So you could look at your historic Misfires that have been cleaned out and add some comments, but then you'd still have your active Misfires because those are the most important ones. So there's a couple of ways that you could certainly store past Misfires, I guess.
Does the program allow for input of peripheral conditions like wet or damp fuses, bad igniters, or related data?
Absolutely. I showed the whole tabular view and the blast tabular view. So those show two different properties. We have whole properties and blast properties, each of which is customizable. You can add as many custom features as you want, and when you do that, they're then able to be filtered and looked at in the future. So I think the example was, you said wet fuses or any other property. You can actually add that as a custom whole property and go into your whole properties for that hole and then just check that box, or you can have a comment. You can even have a range of numbers that you pick from. For example, fume, you could set your fume scale of 1 to 5. Some people use this for tracking drill bits. So you'll just have a drill bit field, and you can assign the serial code of the drill bit to all the holes that were drilled by in that period. So certainly, you know, I'd say unlimited customization on both the specific to the holes, but also specific to the blasts.
How are voids managed? Are those the responsibility of the driller to adjust as needed in the field, or is that a separate parameter that is input prior to the shot and adjusted for at another point in the process?
Yeah, so that would kind of be similar to the last question. Currently, we do not log the full downhole drilling information. That'll come in about 2 versions. So we will have the full geotech logging, which tells you every inch or two what the hardness of the rock is. So if you saw a spike in hardness that, you know, it showed really soft, then we could have a clever feature in there that would just say that this area was, you know, soft enough to probably just be air. But with the current version, that would be either a comment that came in by the driller, or it would be something that, you know, they've either called you and said, look, this hole had a problem, and again, that would be a custom property that you could just add with potentially the depth. So a few ways to do that. Like I said, we're going to get better at that in the future when we get our geotech tools in.
Okay, it looks like those are all the questions we have today. If you do have additional questions later on, please feel free to reach out to Steve. If you are a Maptek client, please post any questions that you have on our website in the users area. If you're not a Maptek client and don't have access to the users area, you can email info@maptek.com or steveputt@maptek.com as posted on the screen in front of you. On behalf of the entire Maptek team, we'd like to thank you for attending today. Please visit www.maptek.com/webinars for a complete list of upcoming and recorded webinars. Thank you and have a great day.